The Chinese company Astrobot has introduced a new humanoid robot called S1, which moves at speeds of up to 10 meters per second and can lift loads weighing up to 10 kilograms. Its speed is sufficient to pull a tablecloth out from under a stack of glasses without dropping them. However, this robot is not only fast but also incredibly precise. The video demonstrates how it performs various tasks: opening and pouring wine, delicately peeling a cucumber, flipping a sandwich on a skillet, vacuuming, and even writing in calligraphic script. The robot's ability to accurately mimic human movements speaks to its high potential for learning. However, the video raises several questions. For example, does S1 have a lower body? All humanoid robots have some means of locomotion, but S1 appears to be a stationary robot. It is also unclear whether S1 will ultimately be launched into production. So far, the Astrobot website provides the following information. The company was founded in 2022 in Shenzhen, and the development of the robot took about a year, with an expected release for sale later this year. The site also states that the parent company, Stardust Intelligence, was founded by Lai Tse, who previously worked at Tencent Robotics Lab, Baidu, and the Hong Kong Polytechnic University. Japanese scientists have created a robot duplicate of the country's Minister for Digital Technology Taro Kono. The official's robot twin is part of a research and development project led by Professor Hiroshi Ishiguro of Osaka University. The research is also part of the Cabinet Minister's project. It was developed to test the possibility of conducting social events remotely. The 175 centimeters tall robot has 52 movable parts, including on its face, arms, and waist. The cybernetic avatar of the Japanese minister has yet to be tested. During the trials, the avatar will interact with people, deliver speeches, and scientists will attempt to determine whether people perceive the avatar in the same way as the minister. The minister himself can remotely control his robot clone. This allows him, among other things, to participate in public events without the need to be physically present there. Such a robot is needed by scientists for a series of studies on people's attitudes toward such copies, and whether such a robot can eventually replace a human in various fields of activity. Researchers are convinced that a cybernetic avatar will increase the efficiency of economic activities, especially if one person manages more than one cybernetic avatar, performing various tasks remotely. At the Abyss Creations factory in California, they have created a hyper-realistic robot named Sarah with artificial intelligence. Sarah is a robotic version of realistic silicone women with smart processing power in her head. She smiles, blinks and frowns, can engage in conversation, tell jokes and quote Shakespeare, recognize faces, and remember birthdays, food preferences, and names. Sarah can talk about music, movies, and books, and that's just a small part of the robot's abilities. For people to feel comfortable in the presence of humanoid robots, they must resemble humans but have some obvious differences to immediately distinguish them from humans. For example, they can be made to look like dolls, with unrealistically large eyes, button noses, and other features that seem cute and endearing, but at the same time clearly signal that this is not a human. However, even such differences do not solve the problems, as scaring can be caused not only by appearance, but also by some human-like actions, such as eye movements. The eye movements of the robot scare people because they are very natural, especially if the robot is looking at you. It seems like it's watching you. Employees of the Columbian Engineering University have created a robot named Emo, capable of predicting human emotions and responding accordingly. Cameras in its pupils allow it to establish eye contact, necessary for nonverbal communication with people. Emo is equipped with 26 muscles, enabling it to perform a wide range of emotions. Its head is covered with silicone material, mimicking human skin. The artificial intelligence model predicts facial expressions by analyzing subtle changes in the interlocutor's facial muscles. Then the AI generates motor commands using the corresponding expressions stored in its database. The robot spent several hours learning from video clips of human facial expressions, observing them frame by frame. To enable the bot to use facial expressions, scientists placed Emo in front of a camera to perform arbitrary movements. After a few hours, the robot established a correlation between facial expressions and motor commands. Emo learned to predict a human smile 800 milliseconds before the person opposite actually expressed it. The experiment's authors are confident that Emo will improve the quality of interaction and help build trust between humans and robots. The rapid advancement of technology, especially artificial intelligence, is making robots increasingly intelligent. Let's meet one of the smartest robots named Alter, which operates based on neural network algorithms. This means that all of its erratic and disorderly movements are entirely independent of any human control. You could say it's alive. Alter appears dressed in a stylized costume for performance, but the most interesting part is underneath this shell. Alter has 42 pneumatic actuators and a central pattern generator, which creates neuron equivalents and enables the robot to move. Alter's erratic movements are based on sensor readings, which can detect noise, temperature, humidity, and proximity to other bodies. Alter was created by two robotics labs from Tokyo and Osaka, and recently it was showcased at an exhibition at the National Museum of Emerging Science and Innovation in Tokyo. The robot has two modes of movement, chaotic and smoother. The neural network decides which mode to use based on the information it receives from the sensors. By calculating the parameters of the surrounding environment, it performs certain movements. For example, if there are many people around, the robot actively moves its torso. Nowadays, the high-tech market has seen a massive influx of hyper-realistic interactive robotic dolls with integrated artificial intelligence, which represent an entirely new type of object for interaction with humans. These robot dolls are successors to animatronic robots, but the main difference from such mechanisms is their incredible realism and the presence of artificial intelligence, fundamentally altering the level of interactivity, function, and nature of interaction. Robotic dolls can only interact within the framework of a predefined social role. Their personality, preferences, behavioral patterns, and speech strategies are predetermined by developers. Researchers note several potential negative consequences, including emotional attachment, desocialization, and the formation of alternative models of social relationships. A separate issue is the discussion of the threat to confidentiality and privacy protection, since robotic dolls are connected to the network to receive updates and store user dialogues. It should be noted that social robots with anthropomorphic interfaces have been used for several years in human communication in various roles. Meet Alan, a robot created by engineer Will Huff and his team on the YouTube channel Will Huff. Alan possesses various abilities, including the capability to learn about the surrounding world, interact with people, and even participate in various experiments. The robot represents a project in the development of artificial intelligence and robotics, which is constantly evolving and improving by its creators. A human-scale robot head and shoulder designed to use emerging technologies such as deep learning AI, object recognition, facial recognition, and motion tracking. The robot is fully compatible with today's smart speaker devices like Google's Home, Amazon's Alexa, and even Apple's Siri. The robot is built on an aluminum frame for strength and lightweight mobility. The high-temperature epoxy shells are designed to be resistant to higher temperature environments. Skins are manufactured with platinum silicone for longevity and endurance. The magnetic and modular design allow for future upgrades. In previous episodes, we told you about an enthusiast named Ricky Ma, who created a humanoid robot, model named Mark I. Quite recently, the engineer showcased the progress of his robot. Mark I has learned to cook various dishes to suit any taste. To create his dream robot, Ricky Ma spent $50,000. Ricky began building his robot essentially from scratch. He 3D printed the skeleton for his creation. In total, 70% of the robot's body was created on the printer. Only the engines, metal mounts, and computer chips were not printed. He programmed the hardware to respond to voice commands. The designer spent a year and a half on the whole project. The robot responds to commands that Ma gives through the microphone. The designer engineer admitted that the project turned out to be quite challenging. Chinese company Forier Intelligence has unveiled an updated version of its robot Forier GR1 and released a new video featuring the robot acting as a physiotherapist. However, the video does not specify whether the robot's movements are controlled by an operator or artificial intelligence. Judging by the information provided, it seems to be an operator, as the company has only stated that the robot is capable of autonomously navigating complex terrain and avoiding obstacles. The company also claims that it is an ideal physical agent for general artificial intelligence, but it appears that the AI for the robot has not yet been developed. In the future, the GR1 will be used in medical facilities, such as assisting immobilized patients in getting into bed or wheelchair. The GR1 can maintain balance while walking and perform various tasks, as stated by Forier Intelligence CEO Zen Ko. The robot can be programmed to sit, stand, or jump, use utensils, and operate various tools. This can set up the GR1 to work as a home assistant or rehabilitation program assistant, as well as serve as a companion for lonely elderly individuals. There are now many types of robots and just as many theories on how to build them, but Dr. Suzanne Gildert, founder and CEO of Vancouver-based Sanctuary, wants her robots to be as lifelike as possible. "I don't think you can have intelligence without some kind of body, even if it is an abstract sense of a body," she said in a recent interview. "All the concepts we have in our head come from the type of data we ingest, which means it is a function of our sensory perception, and therefore, our body." As such, Dr. Gildert created what she calls synths, which not only look like us, but learn by emulating us. In her lab, Dr. Gildert slips into an exoskeleton and stands next to one of the in-development Alpha 3 units, teaching it to move through teleoperation. By being embodied, Sanctuary AI's synths understand their role within an environment, just like we do through experiencing, recording, and replaying until they get it via reinforcement learning. Limex Dynamics robot has learned to walk upstairs like a human. Robotics company Limex Dynamics has announced progress in the development of the humanoid robot, CL1. After improving perception algorithms and body control, the robot has become faster at climbing stairs. Now it alternates legs with each step, rather than taking 2 steps per stair as before. At the same time, the robot's speed and dynamic capabilities have increased. This is also due to hardware updates in addition to software improvements. Furthermore, the robot's structure has become lighter and more impact-resistant. CL1 is one of the few humanoid robots in the world that performs stair climbing based on real-time terrain perception, primarily thanks to the use of Limex Dynamics motion control technology and artificial intelligence algorithms, as well as patented high-performance actuators and hardware systems. The advantage of the humanoid robot lies in its ability to react in real time to changes in terrain, rather than blindly following a predetermined route. Reportedly, Limex Dynamics is the first company in China to apply perceptive control in humanoid robots, successfully performing dynamic stair climbing and descending slopes. A robot dog with a flamethrower attached to its back is now on sale in America. Manufacturer Throwflame first introduced its new creation called the Thermonator last summer, and now it's available for purchase. The company shared a new video demonstrating what the Thermonator is capable of. The video, which lasts just under 2 minutes, starts with the flamethrower on the robot's rear being filled with lighter fluid. Then the Thermonator is seen spewing flames, including one shot showing it jumping while doing so. On its website, the company positions the creation as the world's first flamethrower-equipped robot dog. It costs nearly $10,000. Critics warn that if the robot falls into the wrong hands, trouble could follow, as they oppose the company's intention to sell the robot to anyone interested. However, the developers themselves do not consider their creation to be a weapon. They position the robot dog as a tool for special effects, as Throwflame is actively involved in such systems for the film industry. Apparently, the flamethrower is attached to the Unitree Go 1 robot dog model, a not-too-large quadruped robot, although the creators could have used a larger specimen from Boston Dynamics, in which case the flamethrower would be more long-ranged and powerful. However, engineers may have wanted to use the Spot model, but Boston Dynamics strictly prohibits arming its robots. Meet Fred, an ultra-realistic humanoid robot made for the launch of the 2nd season of Westworld. It took 3 months to complete it. The goal was to fool people into believing the robot was alive. Fred the robot was modeled on a real 55-year-old male, and was brought to life by the robotics company Engineered Arts as a hyper-realistic humanoid robot. The alarmingly lifelike bot is made with silicone skin, real hair, and a complex metal skeleton that allows the robot to make realistic movements. Fred was set up in a pub in London, along with hidden cameras, to see how real members of the public would interact with the artificially intelligent robot, just as in the television series. In the pub, Fred generated conversations and gave details about Westworld on Now TV. Created to engage in natural conversation in real time, his interactions were controlled by Engineered Arts' telepresence system, which uses inbuilt sensors, cameras, and microphones to track what and how people interact. A Japanese university student has created his own humanoid robot for a graduate project, and it's a twin of Yuki Kashiwagi, a singer from the hugely popular Japanese girl group AKB-48. Shown off at the Nico Nico Chokaigi Super Conference in Tokyo, the RoboRen robot depicts Kashiwagi in a long white dress, and an Xbox Kinect sensor built into the chest of the robot reacts to humans nearby, so that the robot turns and fixes her gaze on anyone that enters her field of vision. According to Japanese website IT Media Japan, student Takayuki Todo says that he carved the robot's face out of softwood by looking at magazine photographs. He intends to upgrade the robot with better head tracking, eye pupils, and more expressive eyelids. Todo admits that the resemblance of the robot's face to the real idol is not 100% perfect, and he has designed the facial resemblance from photos in magazines and various meetings such as events in real time. Despite being very creepy, this robot is an impressive achievement for a student working alone. A humanoid robot has started teaching at an American university. Meet Beina. She lectures at the United States Military Academy. Bionic 48 was introduced to the public back in 2012. She was created by entrepreneur Martine Rothblatt in the likeness of her wife Beina. The robot is based on an artificial intelligence system. As a teaching robot, Beina gives lectures on introductory ethics philosophy. She has over 100 students, to whom Beina teaches the basics of ethics, theories of just war, and the morality of using artificial intelligence in society. The robot operates on a knowledge-based system and algorithms. Bionic 48 not only delivers lectures but also answers students' questions. Additionally, Bionic 48 was the world's first student robot. She completed a 16-week philosophy course at the University of Notre Dame de Namur. Afterward, Beina began teaching at the university. Oryx Rentec, a Japanese tech rental agency and a branch of the well-known Oryx car rental agency, has announced the launch of a robot rental service called RoboRen, featuring an android named Mirai Madoka. It serves as a multilingual secretary, proficient in English, Chinese, and Japanese. Bearing resemblance to Toshiba robots, Mirai Madoka may have been co-developed by Toshiba and A-Lab, or exclusively by A-Lab based on Toshiba-like specifications. The robot is displayed at the Oryx Rentec showroom named Tokyo Robot Lab near Tokyo. However, due to its commercial nature and focus on potential renters, access to the showroom is restricted to the general public. Nonetheless, the showroom offers an intriguing array of robots for rent, including Mirai Madoka and various industrial and collaborative models. With its ability to move its eyes and lips, Mirai Madoka exudes beauty and elegance with its long hair. Japanese pub chain Yorinotaki has begun testing a robot bartender capable of pouring beer or mixing cocktails in 40 seconds. The robot is created by QBIT Robotics Company. It consists of a robot arm system that pours and serves drinks, a tablet displaying the robot's emotions, and 4 cameras that locate customers and determine their mood. It takes the machine 40 seconds to pour a beer and 1 minute to mix a cocktail. The robot can recognize customers' faces and use voice calls based on their age and gender to attract clients. To analyze customers' facial expressions, the robot uses a computer vision system and 4 cameras. While the mechanical bartender lacks speed, introverted Japanese people like the novelty of the new employee. There is no need to engage in lengthy conversations or attract its attention to order a beer. The cost of the robot is $82,000. This development could trigger a wave of automation in restaurants and cafes, where young Japanese people are reluctant to work. Chinese company Unitree Robotics has once again showcased its quadruped robot Unitree B2. It is capable of running at speeds of up to 6 meters per second, lifting loads of up to 120 kilograms, and moving continuously on a single battery charge for more than 5 hours. Unitree Robotics already has a whole lineup of quadruped robots. However, the company has now developed a more advanced model, the Unitree B2. The new quadruped robot weighs 60 kilograms. The RoboDog can withstand loads of up to 120 kilograms statically and over 40 kilograms in motion. With a battery capacity of 2,250 watt-hours, the robot can move continuously for more than 5 hours without a load, covering approximately 20 kilometers, and over 2 hours with a portable load weighing 45 kilograms. The dynamic characteristics of the actuators allow the robot to jump over a distance of more than 1.6 meters, leap from heights of over a meter, and run at a maximum speed of 6 meters per second. Moreover, the robot is very stable. B2 can maintain balance on a slippery floor covered with banana peels, even when subjected to pushes from engineers. Unitree B2 can walk upstairs, including backward or sideways. Additionally, the robot can climb 45-degree slopes and move across cluttered surfaces. For spatial orientation, B2 uses LiDAR, depth camera, and a high-resolution regular camera. It is planned that the robot will be used in industries, for example, for remote inspection of objects. Here is a spider robot from the company Festo. Festo specializes in designing robotic clones of creatures from the animal kingdom. Previously, the corporation has developed ant robots, robo-kangaroos, and even a robotic version of an elephant's trunk. The spider robot is designed after the species Cybrenus reckenbergi, which lives in the Sahara and moves by somersaulting. Professor Ingo Reckenberg, who discovered this species of spider, was involved in the development. The spider robot has 8 legs, controlled by 15 motors located inside the mechanism. To perform a somersault, the robot uses 2 legs to push off, while the remaining 6 legs fold into a wheel-like configuration. This method of locomotion allows the robot to move quickly and even climb slopes with an incline of up to 5%. The spider's body contains an inertial sensor, allowing it to recognize its own position in space and determine the moment of propulsion. From a practical standpoint, the spider robot could be considered a terrain scout. It can move slowly and quietly behind rocks, bushes, and other obstacles, assessing the surroundings. In the absence or presence of danger, it can quickly retreat in a folded state. The French company Stanley Robotics has developed a parking robot named Stan. Such a device is capable of accepting a car, taking it to an available parking space and parking it there. If the car needs to be retrieved, the robot will quickly bring it back from the parking. The device is primarily designed to serve parking lots at airports. The new robot Stan will optimize airport parking lots. In particular, it can park cars more tightly. This will allow one parking lot to accommodate more vehicles. In addition, developers believe that the robot will significantly reduce the time required for parking. The robot is capable of moving any type of passenger car regardless of the length of their wheelbase. The robot is a platform on small wheels with movable clamps for the car's wheels. To move the car, the robot approaches it, clamps the wheels, and lifts the vehicle. But the spider robot is far from the only animal that Festo can surprise you with. The bionic flying fox robot, presented by Festo, impresses with its ability to fly like its natural counterpart. Engineers, as you might easily guess, were inspired by the mechanics of the bat's body. Whether at rest or in motion, the robot almost identically mimics the movements of a live flying fox. For example, it can hang upside down by gripping a pole with its paws. When in motion, the robot spreads its wings and alternates between flapping and gliding phases. For the wings, engineers chose not inflatable films, but rather sheets made of Laotian fabrics fused at 45,000 points. Upon closer inspection, one can notice obvious similarities with honeycomb structures. Thanks to this special material construction, the robot can continue moving and maintain altitude even if the fabric is damaged. The bat has a system of infrared sensors that wirelessly transmit data about the surrounding space. The robot is capable of flying in a semi-automatic mode. China has unveiled the humanoid robot Tiangong, capable of running at a speed of 6 kilometers per hour. Tiangong is a humanoid robot that was presented by the Beijing Innovation Center for Humanoid Robots. The robot is capable of running at speeds of up to 6 kilometers per hour, which is a significant achievement in the field of robotics. It is the world's first fully electric humanoid robot capable of running like a human. Tiangong itself weighs 43 kilograms and stands at a height of 163 centimeters. Its lightweight construction and low center of gravity ensure stability during running. The robot is equipped with various sensors for visual perception, an inertial measurement unit, and 3D vision sensors, allowing it to navigate its surroundings. Additionally, it has 6-dimensional force sensors for precise feedback on the force of reproduced movements. Tiangong has demonstrated its ability to move on slopes and stairs without external control, as well as adapt to changing environments. Its agility allows it to adjust its gait when encountering obstacles or uneven terrain. The development of Tiangong opens up new possibilities for the use of humanoid robots in various fields, such as search and rescue operations, disaster response, and in industry. Inform is a display that can physically generate 3D content, allowing users to interact with digital information as if they were interacting with real objects through touch. Inform is a project that can interact with the physical world around it. For example, moving objects on the surface of a table. Remote participants in video conferences can be physically represented, enhancing the sense of presence and the ability to physically interact at a distance. Such displays are intended to be used in 3 different ways: to facilitate interaction by changing the shape and thus the physical purpose of an object, to create dynamic artificial constraints that guide users, and to control existing physical objects. Currently, developers are researching the application areas of such displays. For example, architects could view 3D models physically, which would facilitate the process of sharing work and discussing it. Additionally, Inform would allow 3D modelers and designers to prototype their ideas physically without using 3D printing. Finally, in medicine, computer tomography scans could be viewed as physical models and interacted with. The lawns of Indian Institute of Technology in Kanpur recently witnessed a unique encounter when real dogs encountered a robotic dog. This intriguing event took place during IIT Kanpur's annual tech festival Tech Kriti, and a video capturing the moment has gone viral on YouTube. The video, shared by Dr. Mukesh Bangar, founder and CEO of Mux Robotics, the company behind the innovative robot dog, shows a curious stray dog cautiously approaching the robotic canine. The robot, equipped with advanced AI, responds playfully, even flipping onto its back in a gesture that mimics real dog behavior. The interaction attracts the attention of other stray dogs who join in, circling the robotic newcomer, trying to understand its presence in their territory. The real dog, though a little apprehensive, tries to playfully engage with the robotic dog as the latter tries to reciprocate its moves. Meanwhile, other dogs are also seen trying to figure out the presence of a new dog in their territory as they circle the duo. The video left internet users amused, with many posting an array of comments. While some were thrilled to see the amazing amalgamation of technology and reality, others hailed India's advancements in robotics. Engineers from the ETH Zurich laboratory conducted a test of a 3-legged hopping robot for asteroids in a weightless environment. However, not yet in space but aboard an airplane. The space hopper is being developed to move across the surface of asteroids and other bodies with extremely low gravity, where the robot will search for valuable minerals. The current prototype of the space hopper consists of a triangular body made of aerospace aluminum with hinged legs at each corner. Each leg, in turn, has knee and hip joints. 2 motors move the thigh using a differential drive mechanism, while a third motor controls the knee. The robot is omnidirectional and equipped with deep learning-based software. It is responsible for coordinating leg movements, maintaining proper body orientation during flight, and executing controlled landings at predetermined locations. During weightlessness tests, the robot hopped in a specific direction and attempted to maintain the correct body orientation in the air. In recent years, the field of robotics has seen tremendous advancements, with applications ranging from manufacturing to healthcare. Now, thanks to Dino Robotics, a groundbreaking software has been developed that allows robots to understand and interact with their cooking environment. By using artificial intelligence, AI-based object localization, and 3D image processing, these robots are capable of accomplishing complex culinary tasks, such as seasoning and cooking a steak or preparing a salad with fresh ingredients. The integration of robotics into the culinary world opens up a realm of possibilities. Traditionally, cooking has been considered a skill that requires human intuition, creativity, and experience. However, with the introduction of AI-driven robotics, we are witnessing a paradigm shift in how meals can be prepared. One of the key features of Dino Robotics software is its ability to recognize and understand various objects in the kitchen. Through advanced algorithms, the robots can identify ingredients, utensils, and even cooking equipment. This capability allows them to perform tasks with precision and accuracy, ensuring that every dish is prepared to perfection. Not only do these robots excel at following recipes, but they can also adapt to different cooking environments. By analyzing the surroundings and making real-time adjustments, they can account for variations in temperature, humidity, and other factors that may affect the cooking process. This adaptability ensures consistent results and enables robots to handle a wide range of culinary challenges. Mobile manipulators are expected to become the next-generation automation tool. Tokyo Robotics is one of the leaders in developing various next-generation robots. One of the company's highlights is the mobile manipulator Tolan. Tolan is a user-friendly mobile manipulator that supports the development of next-generation robotic applications. It is ideal for creating autonomous robots that automate material handling tasks in logistics, short-distance transportation in factories, security, patrolling, and more. The robot can operate even in confined spaces due to the asymmetrical placement of its arms. The launch of the robot was announced on August 10, 2022. The company is researching and developing next-generation autonomous robots that perform manipulations combining autonomous movement and image recognition. Kanguro is a robot developed by Japanese engineers that can serve as a personal companion, carrier, and mode of transportation. Equipped with a camera and obstacle detection system, it weighs 64 kilograms and can reach speeds of up to 10 kilometers per hour. Primarily, Kanguro is a transportation device resembling a mix of a scooter and a hoverboard. In this mode, it extends a seat and front wheels and is controlled by body tilt rather than handlebars. Another feature of the robot is artificial intelligence, allowing it to move autonomously. For instance, it can come to pick you up from work or return home if not needed. Kanguro can also be used to transport goods. You can hand heavy packages such as groceries on it, and the robot will follow you. Additionally, according to the developers, you can communicate with the robot like with a friend, as it provides emotional support. Currently, Kanguro is in the development stage and its release date is unknown. However, the creator's idea is that in the future, everyone will have such a robotic assistant that can be summoned like a taxi, providing a comfortable and safe ride to the store or work. The matter of helping drowning people is the concern of the drowning individuals themselves. However, the Portuguese company Norfas Performance intends to challenge this statement by developing the world's first waterborne robot Usafe, whose goal is to rescue drowning individuals along the coast. The robot swims using 2 turbines. They are omnidirectional and operate independently of the Usafe's orientation in the water. Weighing 30.6 kilograms, Usafe has a range of 6 kilometers and a maximum speed of 15 kilometers per hour. It is powered by a lithium-ion battery with inductive charging and is controlled by a waterproof Bluetooth remote control. The advantage of the robot is that it is not afraid of the chaotic actions of the victim, which in the case of a human rescuer could lead to a double tragedy. Moreover, Usafe serves as a warning buoy in the process. This robot has already been adopted by the Italian and Portuguese Coast Guards and is now preparing for release in the United States. Meet Agrobot, a robot for picking strawberry. In the modern world, robots no longer seem unusual. They are gradually replacing human labor in various sectors, including agriculture. There are robotic farms, drones for field scanning, and automated platforms for soil research and processing. Now machines capable of harvesting crops are starting to appear. The company Agrobot has developed a system with a set of manipulators capable of finding strawberry bushes, determining the ripeness of the berries on them, and picking the ripest ones. The Agrobot robotic strawberry harvester is an unmanned robot for strawberry picking. Agrobot can autonomously harvest berries in an area of up to 80 square kilometers in just 3 days. The selection of berries is determined by size and color, which are identified by sensors on the robot. Ripe berries are harvested extremely gently. The robot does not touch them but simply cuts them off along with a short stem. After that, the robot sends the berries to a special container. The machine is fully automated and performs all operations independently. It moves between furrows and rows using a laser locator. It also has a built-in remote control function for farmers who are concerned about system failures. The device's design allows it to be optimized for any farm's characteristics. The Dutch startup RoboRen Marine Technology showcased the Wasteshark unmanned surface vehicle at the CES 2022 exhibition, a floating drone designed to remove harmful plastic waste from the water and return it to shore before it can cause damage. Wasteshark is an automated aquatic drone that can be operated manually or fully autonomously along a predefined route using waypoints for navigation in a specific body of water. The device features a detachable basket where trash is collected, which can be easily removed, emptied, and then put back in place for further use. In addition to collecting surface debris and biomass, Wastesharks can be equipped with sensors, providing users with additional benefits by receiving real-time data from relevant bodies of water through a 4G data transmission portal. Its capacity is about 180 liters of garbage per load, which corresponds to approximately 500 kilograms per day of plastic and biomass with one daily load. Furthermore, the drone uses advanced battery technology, enabling operation on water without emissions and without increasing water pollution. This makes Wasteshark one of the leading solutions in the fight against plastic pollution. Engineers from the Swiss Federal Institute of Technology in Zurich are not giving up on turning their wheeled robot Animal into a fast and agile delivery robot. In the latest tests, the robot had to navigate through a complex urban landscape, and it seems to be handling all types of surfaces and terrain easily. Perhaps in the future, we will see an army of such delivery robots on the streets of our cities. Animal overcomes obstacles using a trial-and-error method. It assesses the obstacle and chooses a way to overcome it. The machine can climb over it, jump over it, crawl under it, or apply any combination of movements that have worked in the past. The creators of the robot have taken a comprehensive approach to its training, combining the previously implemented project's software control and machine learning technologies. The movements of the self-learning robot are surprisingly graceful and efficient, setting it apart from most similar machines. Machine learning algorithms help Animal assess the landscape and navigate it. The robot flexibly applies a library of movements as needed, which is constantly expanding. This helps the machine confidently maneuver on uneven and slippery surfaces. The Festo Bionics team has developed the Bionic B robot, a flying robot capable of autonomous flight as part of a group of robots. The B robot flaps its wings, making forward and backward strokes at an angle of 180 degrees. The wings are actuated by a brushless motor. 3 servo motors are used to control the direction of movement, shifting the wings to create variations in lift. To achieve autonomous behavior for a swarm of 10 B robots, an internal localization system using ultra-wideband technology is employed. 8 UWB beacons are installed on 2 levels of the facility, allowing for precise determination of the robot's positions in space. Each robot receives signals from the UWB beacons, autonomously determines its distance to the transmitters, and calculates its position in space using timestamps. During swarm movement, the B robots follow trajectories defined by a central computer, as high spatial and temporal accuracy is required for a flight with no collision. Additionally, route planning must also consider potential interactions caused by air turbulence. Norwegian Kare Halvorsen has introduced his new invention, a robot named Morp Hex Mark II. It can retract its legs and transform into a rolling sphere. Perhaps this is the first hexapod robot that can controllably roll uphill. Halvorsen's new robot, Morp Hex Mark II, is divided into a large number of sections, each of which has 2 motors. This robot is capable of rolling on the ground. At the right moment, it can unfold and turn its panels into legs, allowing it to walk. They enable the device to roll, retract, and extend its legs. It is worth noting that the creator of Morp Hex Mark II managed to design and build a device that would most accurately be called a dual hexapod, given the number of limbs it has, which totals 12. The Norwegian constructor labeled his new model as Mark II, unlike the predecessor robot labeled Mark I, which could only move in circles, while the new robot can roll in a straight line. According to the constructor, controlling the robot is like driving a remote-controlled car. The Japanese company Melton, specializing in the development of avatar robots, showcased the capabilities of its first robot Melton Alpha. The Japanese robot Melton Alpha is controlled by an operator using 2 gloves and joysticks attached to beams, the movement of which the robot replicates with its hands. To see what is happening around the robot, the operator can use virtual reality glasses. According to the developers, the hands of Melton Alpha accurately replicate the structure of the human hand, taking into account the location of muscles and tendons running to individual fingers. Polymer elastic cords are used for this purpose. Pressure sensors are also installed in the robot's fingers, and a feedback system provides haptic feedback. Due to this, the robot can perform very precise movements, pick up an egg or a laptop, hold a playing card. At the same time, the robot's hands are quite strong. With just 2 fingers, it can hold a 2-liter water jug, and with both hands, it can hold a load weighing about 4 kilograms. Melton reports that they have successfully tested controlling the robot from a distance of 18,900 kilometers, but no other results are currently known. A robotic kiwi fruit harvester developed in New Zealand is expected to greatly aid the industry in the coming years. It has been developed to help pick some of the more than 3 billion kiwi fruit harvested in New Zealand each year. Labor shortages and arrival of new varieties have made getting the fruit off the vine at the right time a huge challenge for growers. Now a team of scientists and engineers working with Waikato and Auckland universities have developed a new robotic picking machine designed to move along beneath the vines, gently taking the fruit as it goes. The mobile robot automatically moves to the bag or picker location when the message is received, and the picker can empty the bag into the robot. The robot then takes the fruit to the desired destination for sorting or packing, and then repeats the process when another bag is filled. An array of cameras are at the heart of the machine, which uses a series of learning algorithms to map the canopy above in 3 dimensions. The system retains the use of a human fruit picker while introducing automated robotics concepts. Japanese company DensoWave has introduced its high-speed collaborative robot Kobata. The new collaborative robot Kobata is a high-speed robot that ensures productivity and safety. Kobata is an ultra-lightweight collaborative robot weighing only 4 kilograms excluding cables and has a payload of ½ kilogram. Programming is simplified due to a graphical user interface that is easy to install and intuitively operated. Tasks can be automated in a short time and include simple assembly, classification work, and inspection. It is equipped with a direct teaching function, allowing a person to teach the robot movements by directly moving its arms, so anyone can teach the robot new movements without programming knowledge. Kobata can also be remotely controlled using a tablet PC touch panel. The robot is suitable not only for replacing simple assembly, sorting, and inspection tasks, but also for labor-intensive tasks, and by deploying Kobata, a flexible production line can be built. Introducing the world's first soccer-playing robot dog. The Dribble Bot, developed by MIT, can play soccer on grass, mud, and sand. The team of developers has prepared their creation for RoboCup, a major international competition founded back in 1996. But why prepare a 4-legged robot for a football championship and teach it ball handling skills? It might seem like a huge investment of time and resources for a simple game. However, the developers disagree. They believe that soccer is an excellent opportunity to test the robot's movement skills, agility, and decision-making ability. During the game, the machines receive additional training and undergo testing. It is especially important for the robot to be ready to move not only on parquet surfaces, but also on grass, sand, mud, and snow. Football training helps to develop these skills. While Dribble Bot can't yet be called a perfect robot, it plays soccer quite decently, but stairs and inclines still pose a problem for the small robot dog. Boston Dynamics unveiled Sparkles, a specially dressed robot dog named Spot. The costume makes Spot resemble a giant toy dog. Developers stated that it was created to explore the intersections of robotics, art, and entertainment. In the presented video, Sparkles dances alongside the original Spot. The robot dog's dances became possible thanks to Choreographer, a tool for creating and controlling movements to music via the Spot API. Choreographer, which became available last year to clients in the media and entertainment industry, bridges the gap between the creative process of a traditional choreographer and the technical process of programming a robot. In simpler terms, Choreographer analyzes Spot's physics and the surrounding environment, prioritizing balance before following the specified steps. Due to such sports intelligence embedded in the robot, you can simply give higher-level instructions, and Spot will do the rest. If asked to do something physically impossible, or if encountering an issue like a slippery floor, Spot will find a possible movement most similar to the requested one and execute it instead, similar to what a human dancer would do, Boston Dynamics stated. Warehouse logistics is reaching a new level with the unmanned forklift truck Fola from the developer iPlusMobot. Such a robot is equipped with 3-dimensional perception technology of the surrounding environment, allowing it to perform cargo handling and storage operations without the involvement of an operator. The forklift can autonomously detect and navigate around obstacles in its path, as well as pallet stacking on racks. Also, thanks to integration with the warehouse planning system, the robot autonomously selects the optimal route for each specific case. The machine can lift loads weighing up to 1,400 kilograms to a height of up to 1.6 meters. Our Fight, a fighting game featuring robot suits, was demonstrated at a preview event for Sushi Tech Tokyo 2024 in Tokyo's Chiyoda Ward on April 9, 2024. The previous robot suits by Skeletonics, exoskeleton suits, had a strong showing element, such as demonstrations at events. But R-Fight is considered a new concept of technosports using the robot suits. When you battle each other using weapons, a sensor embedded in the suit detects damage, creating the sensation that you are participating in a fighting game. This time, R-Fight was created not by Skeletronics, but by the Superhuman Sports Project. Based on human augmentation engineering, it envisions a human-machine form of sport, where superhumans with abilities surpassing human physical capabilities compete against each other. Today, there are many types of esports and VR sports, but for people who want to sweat in person, something as straightforward as R-Fight could be important. Engineers have created the world's first silicone robot doll with artificial intelligence. It cries when hungry, wants to sleep, seeks comfort, needs a diaper change, and can feel discomfort. Essentially, it's an artificial child created by scientists that simulates a real baby. This silicone robot doll was created by sculptors from the Spanish company Babyclon. The company was founded by hyperrealistic sculptor Cristina Iglesias. Babyclon manufactures dolls that visually resemble real babies to the maximum extent, although they are not robots in the conventional sense. According to the Babyclon website, the company positions its infants more as avatars and animatronics, which can be characterized as robotic moving babies. The new toy models created with artificial intelligence have several new features. For example, they stop crying when you give them a pacifier. High-quality surgical silicone, which closely resembles human tissue in terms of hardness, elasticity, and weight, is used in the manufacturing of the doll. None of the stages of doll creation take place at a factory. They are entirely handmade. At last year's CES 2023 exhibition, a high-tech electric wheelchair called SiwoBro, developed in Switzerland for people with limited mobility, was showcased, and it truly amazed many people. According to its creators, it is the world's only self-balancing wheelchair capable of ascending and descending stairs without a ramp. The wheelchair itself is incredibly convenient. SiwoBro is not dependent on torso size. The seat can expand from 45 to 87 centimeters. The backrest is adjustable and can be customized according to personal preferences, and the proprietary mobile application provides information about speed and current mode, as well as controls for lighting and key settings such as joystick sensitivity. Weighing 162 kilograms, this personal transport can travel 25 to 35 kilometers on a single charge at speeds of up to 10 kilometers per hour, which puts it on par with electric scooters. However, the main feature of SiwoBro is its ability to move on regular stairs. The wheelchair can independently climb up to 30 steps per minute, each of which can have a maximum height of 20 centimeters with a slope of up to 36 degrees. It can also overcome 5 centimeters obstacles in the wilderness, in case the user gets tired of urban locations and wishes to rest without outside assistance in remote areas. Currently, developers have sold about 30 units of SiwoBro at a price of €33,500 each. Investors have evaluated the product as high potential. The engineers from Kim Lab presented their innovative creation, the interactive robotic backpack system, known as PAPRAS. The backpack features 4 arms and is controlled by the user's upper body movements, demonstrating the expansion of the user's physical abilities with extra limbs. This system, envisioned to give users superpowers, incorporates interchangeable additional limbs that provide enhanced capabilities. The development of such a complex control system that enables simultaneous control of multiple limbs is currently underway, bringing the idea of Dr. Octopus-like abilities closer to reality. While still a work in progress, the potential benefits and applications of this technology are vast, ranging from enhancing human capabilities to aiding in physically challenging tasks. Scientists have developed a prototype robot called RingBot, inspired by the wheeled battle droids from Star Wars. It is a self-propelled wheel that uses extendable supports for control. RingBot is powered by 2 motorized drive modules with small gear wheels located inside the wheel rim. The supports prevent it from falling and help it to stand up if it does. During testing, it reached speeds of up to 5 kilometers per hour. In the future, such robots could be deployed in delivery services. Faster and larger bot like this could use cameras, sensors, and GPS to autonomously navigate through traffic on crowded city streets delivering goods. It will be capable of maneuvering in tight spaces. A future version could also feature 4 wheeled legs, allowing it to climb stairs. In Japan, a demonstration of an autonomous robot named Noki was showcased. Noki is capable of knocking on doors, opening them, and delivering drinks to hotel rooms. Currently, the robot can only open doors that it already knows, but developers are working to enable it to open doors it encounters for the first time as well. In a demonstration experiment conducted at Akashi Works, Noki moved to the front desk based on a map it had memorized and located the door handle using sensors on its head and arms. It grasped the door handle with its right hand and knocked with its left, then moved forward into the partially open space to open the door wider. Placing a tray of drinks on a cart, the robot entered the room and said, "Here are your drinks." Noki's body is attached to a four-wheeled cart, standing at a height of 1.5 meters and weighing 75 kilograms. Its neck can extend upward to a height of about 1.9 meters. Another feature of the robot's design is its two hands, each with 3 fingers. To enable the robot to recognize the position of the door handle in the serviced room, its hands and head are equipped with special sensors. It is expected that this robot will help compensate for the shortage of workforce due to Japan's declining population. Engineers from the Unleashed project recently presented the kitchen skills of the trainable home robot Aloha with open source code. By the way, engineers from Google DeepMind are also involved in this. Now they are teaching robots to tie shoelaces, hang laundry, and repair other robots. At each station they are fully autonomous. Moreover, when engineers taught one bot to hang a shirt and threw a sweater into its workspace, it generalizes the knowledge and tackle the new task without prior training. But the most impressive demonstration was the replacement of fingers on another robot, evoking memories of Skynet, especially considering that we are about to be introduced to a general artificial intelligence. What do you think about this? Should robots repair each other themselves, or is it better to trust humans? Robots are perfect for performing simple, monotonous, and dirty tasks. This was the guiding principle for the startup Somatic when developing a commercial toilet cleaning robot. In bathrooms, everything is bolted to the floor, which is ideal for robotics. The robot only needs to survey the room once, explains company co-founder Michael Levy. Using a VR simulator, the development team demonstrates tasks such as spraying cleaning agents, wiping surfaces, vacuuming, or drying. The team calls it the worst video game. After cleaning, the robot autonomously travels to recharge and replenish cleaning supplies as needed. This autonomous cleaning robot navigates elevators, easily finds bathrooms, and performs routine cleaning tasks, including floor mopping, disinfection, and vacuuming. According to the leasing terms, the robot will work approximately 8 hours a day. It can navigate elevators and open doors on its own. The company plans to lease it for $1,000 per month. As noted by TechCrunch, Somatic already has several clients, including Facebook, Amazon, Apple, Netflix, and Google. Japan's Chukyo University and AIST demonstrated a dual-arm robot performing a Japanese tea ceremony at a press preview for the C-Tech Electronics trade show in Chiba. The key new technology is the recognition of the functions of everyday items. Everyday items such as cups and spoons have functions that are evoked by their shapes, such as small indentations for scooping and large indentations for storing water. The robot recognized the type, position, and function of the tea utensils in front of it, such as teaspoons and ladles, and made tea without detailed programming in advance, such as determining which utensils to grasp and how to carry them. When humans see a cup for the first time, we can instantly identify it as a cup. However, in order for the robot to do this, it needs to use approximately 300 cups to make it aware of what a cup is in the first place. The startup Nuni has unveiled an upgraded version of its walking chair, the Chairless Chair 2.0. The chairless chair was originally developed back in 2014. It is an exoskeleton for the lower body that does not impede walking but provides support when sitting. The chairless chair supports the legs of a person, such as a factory worker, who is required to spend a lot of time in a static vertical position. The design of this walking chair easily attaches at various heights from the floor, allowing the worker to relieve joints from harmful strain. It is anticipated that the use of this development in the future could help increase labor productivity and preserve the health of particularly mobile employees who need to occasionally work at terminals or multiple workstations. Among the improvements of the new model are a 25% weight reduction, a thinner and more comfortable design, lighter, more flexible, and reliable shoe connections, as well as an increased user height range. It can be adjusted for users ranging from 1.5 to 2 meters tall. As an additional bonus, Nooni claims that sitting on this device helps strengthen back and thigh muscles. Here is one of the most advanced artificial intelligence-powered transportation devices developed by Toyota. The Toyota concept, iWalk, is a personal transportation vehicle designed for areas where the use of cars is prohibited. Essentially, it is an equivalent of a gyro scooter, but with 3 wheels and a control joystick intended to reduce the driver skills required. Even elderly people can operate the Toyota concept. Moreover, as the speed increases, the concept iWalk expands, increasing the wheelbase for additional stability. The range on a single charge is from 10 to 20 kilometers, and for communication with artificial intelligence, a display in the form of a sphere on top of the joystick is provided. Toyota has announced that it will begin testing vehicles with the AI agent system on Japanese roads later during this year.